Welcome to our podcast. Today, we're diving into an exciting topic at the intersection of technology and creativity, time-varying mesh compression. Specifically, we'll be discussing a novel approach titled TVMC, time-varying mesh compression using volume-tracked reference meshes. It's a mouthful, I know, but don't worry, we're here to break it down. So imagine a world where digital mesh models, which we often see in animations or video games, can be compressed efficiently without losing quality. This is not just about saving space, it's about enhancing visual experiences. And who wouldn't want to strive for a more immersive environment? Now, to help us understand this fascinating concept, let's start with the basics. What exactly is a mesh in the digital world? Well, think of it like a flexible wireframe model of a 3D object. Just like how a puppet has a frame that helps it hold shape, a mesh defines the shape of 3D objects in digital space. These meshes can represent anything from a basketball player making a leap to a fantastical creature in a game. Now, as digital assets become more complex, the need for efficient handling and storage grows. Here's where TVMC comes in. It's developed by a team led by Guodong Chen and combines tracking techniques to compress these time-varying meshes. This tracking makes sure that the mesh adjusts seamlessly to movement, much like how our bodies adjust when we move. It's about preserving the essence of motion while optimizing storage. But how do they achieve it? Let's take a closer look at the steps in this process. The core of the technique involves something called ARAP volume tracking. Now, don't let the jargon intimidate you. ARAP stands for as rigid as possible, and it's a fancy way of saying they keep the mesh as close to its original shape as possible while allowing movement. One of the interesting parts of this technology is the use of a reference mesh. This reference acts as a baseline, taking into account the transformations needed as the mesh moves. Imagine having a still photograph of a running athlete that captures their best form. It's this reference that helps correlate all their dynamic movements. And, music to the ears of the developers, this process helps in reducing storage requirements significantly. Now there are several steps to set this up, from building a Docker image, sounds techie, right, to generating reference centers and calculating transformations. If you're curious about the nitty-gritty details, we'll include links in the show notes. The real kicker lies in how they compress the output. Think of it as putting a huge pillow in a vacuum bag. You're squeezing out the unnecessary fluff to make it more manageable. In this case, they use an encoder called Draco. It's a compression algorithm that enables efficient storage and speedy computation of these mesh files, making them easier to share and use across platforms. So, what benefits do you think we might see from this technology? Well, for artists, animators, and developers, it means faster workflows and the ability to create more detailed and complex animations without blowing up their storage requirements. The potential for enhanced virtual reality experiences is another exciting possibility. Imagine an immersive environment where everything feels fluid and realistic without lagging or losing fidelity. Now let's wrap up. If you're intrigued by the world of 3D modeling and compression techniques, we encourage you to explore this and consider what possibilities lie ahead. TVMC opens up a world of efficiency and creativity that could transform digital interaction as we know it. Thank you for joining us in today's podcast. We hope you found it informative and inspiring. Until next time, keep imagining, creating, and exploring the endless possibilities in technology.